This is lesson 3.3, and today we're going to learn about proving lines are parallel. So this theorem right here is from the last section that we did, and what it was talking about was the fact that corresponding angles, let's see, if the lines are parallel, then the corresponding angles are congruent. So what I want you to do right now is, how about some paper, pen, and I'd like for you to go ahead and write the converse of this conditional statement. See if you can write the converse of this. Press pause and go ahead and write the converse. Alright, let's see if you got it right. Basically, if two coplanar lines are cut by transversal and the corresponding angles are congruent, that means that the two lines have to be parallel. So if we can show that angle 1 here and angle 2 are congruent, that means that we can conclude that the lines are parallel. Go ahead and press pause and write that down. Now let's look at an example of how we can use this. So if you look at this drawing right up here, we have two lines. Notice they're not marked as parallel. And we have a transversal, and we have all the angles that are formed all marked with numbers. And if you take a look here, we have angle 1 is congruent to angle 5. So that's here and here. And as long as those two angles are congruent, what can we conclude from that? That line L and line M are parallel. Next we have a postulate, and remember that postulates are statements that do not need to be proven as true. It says through a point P not on a line L, there's exactly one line parallel to it. To make better sense of this, let's see if we can go ahead and make a drawing. So we have a line, and we have a point that's not on the line. And what this is saying is that there is exactly one line that goes through here, through this point right here, that would be parallel to the first line. We can actually show that lines are parallel using the converse of all of the special angles that we talked about last time. So here we have the alternate interior angles. If they're congruent, the lines are parallel. Here we have alternate exterior angles, 3 and 4. And if they're congruent, that means the lines are parallel. And here we have the same side interior angles, and if they add up to 180 or supplementary, then they are also parallel. Take a moment and copy those down in your notebook. So here's an example of a proof. We have our given information right here. We have a drawing, and it says L is parallel to M. So here's L and M, and the markings for parallel are here and here. And it says angle 1 is congruent to angle 3, angle 1 and angle 3 are congruent. I'm going to go ahead and I'm going to mark that like so. Alright, and what are we trying to do? We're trying to prove that R is parallel to P. So this line is parallel to this line. So we start off by saying L is parallel to M, and that's given. Since those lines are parallel, we can say angle 1 and angle 2 are congruent. Why can we say that? Because they are corresponding angles. Then we can say angle 1 and angle 3 are congruent, because that's given. And lastly, we can say angle 2 is congruent to 3. So why can we say that? Well, if 1 is congruent to 2 and 1 is congruent to 3, that means 2 is congruent to 3. That's called the transitive property of congruency. And then lastly, if angle 2 and 3 are congruent, which is right here and here, then that means that the lines are parallel. Why is that the case? Well, those are alternate exterior angles, and if the alternate exterior angles are congruent, that means that the lines are parallel. So this is an example of a proof that is at the just right level for you. something that you might be expected to do on a quiz or a test. All right, here is another sample proof. And again, we've got a drawing right here. We've got some given information here, and we're trying to prove that two lines are parallel, the XY and WV. So we've got our given information here. We've got a statement, angle 2 is congruent to angle 3. I'd like you to, on your paper, fill in what the reason might be, and then lastly, what will be the final step and what is its reason. Go ahead and press pause and try it on your paper. And in a moment, I will show you the solution. All right, angle 2 is congruent to angle 3 because of the transitive property of congruency. This is that angle 1 is congruent to 2 and angle 1 is congruent to 3. So that means that angle 2 is congruent to angle 3. And then lastly, we can say that the two lines are parallel, which by the way is always what we're trying to prove. That's always the last statement. Why can we say that? Well, if you look at angle 2 and angle 3, those are alternate interior angles. So the converse of the alternate interior angles theorem says if the alternate interior angles are congruent, that means that the lines are parallel.